Hello friends, so we have a question on probability distribution. We are given that the time work T, which is given in hours per week by employees of a large company, is normally distributed with a mean of 42 and a standard deviation of 10.7. In the A part, we have to find the probability that an employee selected at random works more than 40 hours per week. So we have to find the probability that an employee works for more than 40 hours per week. So our mean is 42. Standard deviation given to us is 10.71. So we can identify the value of Z score, that would be x minus mean divided by sigma. So here x is 40 minus 42 divided by sigma, that is 10.71. So we get a value of minus 0.19. Now using a standard normal distribution table or our calculator, we can find the probability that a standard normal variable is greater than minus 0.19. This probability will approximately be equals to 0.574. So this is the answer for the part A. Now let us move on to the part B. In the part B, we are given that a group of 4 employees is selected at random and each employee is asked in turn to work for more than 40 hours. Now find the probability that the 4th employee is the only one in the group who works for more than 40 hours. So first 3 are not working for more than 40 hours. So the probability that the only 4th employee works for more than 40 hours is that 1 minus the probability that 3 employees are not working for more than 40 hours, that is 1 minus 0.574 to the power 3, and the 4th employee is working for more than 40 hours. So you can simplify this. This will be 0.4258 raised to the power 3 multiplied by 0.574. You can simplify this to get 0.0443. Now let's see what is there in the third part. In the third part, it is given that a large group of employees work more than 40 hours. And out of those employees, we select another group and we have to find the probability that this employee works less than 55 hours per week. So what we have to find is that the probability that an employee works for less than 55 hours, given that the sample contains employees working for more than 40 hours. So we have to find this probability. So this is basically case of probability of A given B. So the probability of the event B is already known to us, that is the working for more than 40 hours. This is 0.574. Now let us try to find the probability of working less than 55 hours but more than 40 hours. So this will be the probability of an employee working less than 55 hours minus the probability of an employee working less than 40 hours. So for working less than 55 hours, we will have to find the Z score, which will be 55 minus 42 divided by 10.7. This will be 1.214, and the probability for T less than 55 will be 0.8869. Similarly, for probability T less than 40, Z score will be 40 minus 42 divided by 10.7, which is minus 0.19, and the probability for T less than 40 will be 0.4247. So the probability of working between 40 and 55 hours is 0.8869 minus 0.4247. So this comes out to be 0.4622 approximate values. Now we needed to find the probability of an employee working between 40 and 55 hours, given that the lot contains employees working for more than 40 hours. So this will be 0.4622 divided by 0.574. So this comes out to be approximately 0.805. So this is the solution of the C part. The solution of the second part of C. In the second part of C, we are given that the 10 employees are selected at random from this large group, and we have to find the probability that exactly 5 of them work less than 55 hours per week. Anyway, they are working for more than 40 hours also. So this probability is basically a binomial distribution. So we have given 10 employees, we select 5 employees out of 10. Then those 5 employees will be working for less than 55 hours. The probability is 0.805 raised to the power 5. And for rest, not working for less than 55 hours, the probability is 1 minus 0.805 raised to the power 5. So you can simplify this. This is 252 multiplied by 0.338 multiplied by 2.819 into 10 raised to the power minus 4. So this comes out to be approximately 0.024. Now let's see what is there in the D part. In the D part, we are given that the probability of working between A to B hours is 0.904. Probability of working more than B hours is 2 times the probability of working less than A hours, and anyone working less than A hours is considered a part-time employee. So we have to find the maximum time. So we have to find the value of A. Now we know the probability of anyone working less than A hours plus probability of anyone working between A to B hours and the probability of anyone working for more than B hours, the sum should be equals to 1. This is the all possible cases. Now this is given to us as x. This is given as 0.904, and this probability is given as twice of x. So we can solve this for x. The value of x will be 0.032. Now we know the value of probability is 0.032. Now next step would be to find the value of t, for which the probability is 0.032. So we need to use the standard normal distribution to find the corresponding value of z score. The corresponding value of z-score using a standard normal distribution table or a calculator will be equal to minus 1.85. Now you can see the value of t will be equals to the mean plus z-score into sigma. So the value of mean is nothing but 42. Z-score we have already identified as minus 1.85 and the standard deviation is 10.7. So you can solve this simple calculation and find the value as 22.18, or you can approximate it as 22.20 hours per week. So anyone working for less than 22.20 hours per week is a part-time worker. So this is your solution, and for more such questions and their solutions, do visit our website iitnacademy.com and register for regular updates.